Welcome back. This is topic lesson 7.1. We're going to talk about trig ratios. So some of you might have remembered this content from your geometry class from last year, and it's going to be some content we'll be reviewing, and then we will talk about some new things. And for those students who are interested in going into depth for the trig ratios, I would strongly recommend you take on the classes of math analysis for next year or the pre-calcs. We will talk about a lot of the trig functions in pre-calc and math analysis. So first, let's go back to our lesson 7.1, trig ratios. The essential questions would be, how can trig ratio help us find the other sides and angles in triangles? So one thing I'd like to remind students when we talk about trig ratio is there are three sides to a triangle. That's why you see the tri, the prefix triangles. There are three sides to a triangle. There are three angles to a triangle. Okay, let's take a look at example number 1. Before we go into the examples, I would like to pull out the definition of trig ratios. So just a quick refresh of your memories. The hypotenuse, so you see that the hypotenuse is always the longest side, and then the angle theta. So make sure you mark your angle thetas. So for this one, I'm just reminding you, you can put it here, angle theta, or you can put it here. It's up to you. But once you replace the positions, the adjacent side and the opposite side will be different. Adjacent side is always the one that's close to the angles that make up the angles. The opposite side is going to be right across from the angles, the openings opening to, the angles opening to. So if you remember your sine, cosine, tangent definitions from the SOHCAHTOA, so I'm going to write it down, SOHCAHTOA. So these are taking the first letters of each. Sine is opposite over hypotenuse, opposite over hypotenuse. So you can see that it's taking SOH. Cosine is taking the adjacent over hypotenuse. Adjacent over hypotenuse. Again, it's taking the first letter of each. And then tangent would be T. Tangent is opposite over adjacent. So hopefully you'll remember this, and there's nothing much to help you if you don't remember the definition. That's the way it is. And then for this lesson, we're going to extend that to its reciprocals. And hopefully you remember what does the definition of reciprocal means. It's basically flipping it. So sine and cosecants are reciprocal of each other. Sine and cosecants are reciprocal of each other. So cosecant would be hypotenuse over opposite. Secant is the reciprocal of cosine. So secant would be hypotenuse over adjacent. And then cotangent is the reciprocal of tangent. So please remember that I kept using the word reciprocals. And as you can see, I simply flip the original ones to get my definition for cosecant, secant, and cotangents. So make sure you review this. You might need to come back to this a lot. So that should be like a big, good reference sheet for you. Now let's go back and take a look at example number 1. Okay. So in case if you forget, let me write down the definitions down here so you have the reference right away again. So sine theta equals what? Sine theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. And then cosecant is hypotenuse over opposite, secant hypotenuse over adjacent, and cotangent adjacent over opposite. So hopefully this would be the second time to remind you here. Okay, so how do you find the ratios for the given figure here? So I have a triangle. So the three sides are written down, the hypotenuse. So if I'm doing this question, I would first put down hypotenuse is always the longest side. And between 12 and 35, which one is the adjacent? Which one is the opposite? Do you remember I said the angles, the side that makes up the angle is always the adjacent. It's next to it, so it's called the adjacent side. And the angles open up to would be opposite. Okay, do you see that 12 is right across from, or the opening up to the angle theta? So with this, hopefully you'll be able to quickly recognize. So what's sine theta? Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent is opposite over adjacent. So do you see that I'm just writing the numbers down? I'm not thinking anymore once I put down the hypotenuse, the adjacent, the opposite. How about cosecant? Secant and cotangent. Would you like to go over the definition again? Would you like to use the definition to go over and write out the numbers? Well, you can definitely do that. But for me, I will just take this number and take the reciprocals. So what does it mean by reciprocals? I flip the numbers. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Again, I flip it. And tangent is the reciprocal of cotangent. So this way, I don't really have to remember the other three definitions. I'm just using the reciprocals. Now let's take a look at example number 2. So knowing that tangent theta equals 15 over 8, what are the other ratios of theta? Well, for this type of question, what do I do first? I normally draw a picture to help me visualize it. Okay, it's really hard for me to think about numbers. So I would like to make a sketch. So the tangent theta, okay, so I put down theta. And what's the definition of tangent? So in your head, again, refer back to opposite over adjacent. Opposite, so that means opposite. So the side that's the angle open to would be opposite. So this is opposite. The side that makes the angle, this would be 8. So this is adjacent. Well, what's the difference between example number 1 and this one? We don't have the information for the hypotenuse. So what do we do? So do you see that it's a right angle? So we can definitely use Pythagorean theorems. Pythagorean theorem tells you that so the hypotenuse square is equal to adjacent squared plus opposite squares. Adjacent square plus opposite squares. So what's 8 squared? And what's 15 squared? So 64 plus 225, we have 289. And what's the square root of 289? Square root of 289 is 17. So we can calculate. So every time when you miss a side, you can always refer back to the Pythagorean theorems. Now, do we have 3 sides? Does this bring us back to what we have like example number 1? It does look like it's just like example number 1. We have 3 sides, right? Opposite, hypotenuse, and adjacent. So can you write out the trig ratios? So what's sine theta? Sine theta is opposite over hypotenuse. So sine theta equals 15 over 17. Cosine theta equals 8 over 17. Tangent theta we already given, so I'm just repeating it here again. 15 over 8. And then how about the other three? So once again, I'll take the reciprocal for cosecant from sine. That would be 17 over 15. And secant would be the reciprocal of cosine, and that's going to be 17 over 8. And then cotangent is going to be the reciprocal of tangent, which is 8 over 15. So as you can see, once I have the information for the first three, the other three is just flipping from top to bottom, bottom to top. Or you can say that I'm swapping the numerator to the denominators. And that's example number 2. Now move on to example number 3. Example number 3 is a word problem. An 84 feet fire truck ladder leans against a building at a 55-degree angle, while they'd be able to reach a window 75 feet up the building. And there's information for the truck. The truck is 8 feet tall. So I'm just writing it here to show you my graph is not. Again, when it comes to this type of word problems, I like to give myself a sketch so that it helps me understand better with the scenarios, the story here. So basically, the truck itself is 8 feet tall, and then the ladder, so you see that the ladder is 80 feet leaning against the buildings, which is 55-degree angles. So what should we need to calculate first? We need to know the height, right? So as you see, the dashed line I'm marking here, is it going to be tall enough to reach the 75 feet height? So let's take a look. So I'm going to take sine. We know that the opposite, so this would be opposite from the angle 55. So that's the opposite. So that's why I'm using sine. Sine 55 is equal to, I don't know the opposite side, but I know the hypotenuse is 84. So using your calculator, make sure that you check your mode. You see if it's in degree, then you are good. If it's not in degree, make sure you change it back to degrees. So there are two modes in your calculator. One is called the radian, the other is degree. So make sure you are in the degree mode so that you get the answer correct. So multiply both sides by 84. I calculate the x, the opposite, to be, so using your calculator, we get the answer for opposite equals to 68.8. But don't forget the height of the truck. We have to include that as well. So we have to add the 8 to know the total height. So 68.8 plus 8, that's 76.8. So is it higher than 75? So obviously it is. So the answer is going to be a big yes for this question. So it will reach the height of 75 feet. Example number 4. So that's a special triangle. If you remember from your geometry class, you could quickly find the answers. So if you don't, let me just go through the process again. So hopefully it'll bring back your memories. So this one is asking you to find the ratio of cosine 45. Cosine 45, again, I make myself a sketch of a triangle 45. And if you remember that 45 is a very special triangle because it's isosceles right triangles, meaning that this side and this side are congruent. They are the same length. They are congruent. So if I make this one as 1, this one will be 1. If I make this as 2, then this one will be 2. Okay, and so on. But we are missing the hypotenuse again. So what is it? Of course, like I said, if you remember it, you can quickly write out the answers. But if not, you can always use the Pythagorean theorems. So what is it? So again, hypotenuse would be 1 squared plus 1 squared, right? So I'm using 1, okay? So I'm going to erase the, let me erase the 2 so so I'm not confusing you. So I'm going to erase the 2. I'm using the 1 to calculate my hypotenuse. And what is it going to be? What's 1 plus 1? So it's going to turn out to be 2. So my hypotenuse is going to be taking the square root on both sides. So square root of 2. Hypotenuse would be square root of 2. So this way I can write out cosine 45 equals, what's cosine 45? Cosine is adjacent. So I take the adjacent. So this is the adjacent over the hypotenuse. Adjacent over hypotenuse. And do you remember for this, we have to take out we have to do the rationalize. We don't keep the denominators as an irrational number. So we have to rationalize it by multiply top and bottom with square root of 2. Multiply top and bottom with square root of 2. And what do we get? So 1 times square root of 2 is square root of 2. And square root of 2 times square root of 2 is square root of 4, which is 2. So it is no longer irrational numbers. So square root of cosine 45 degree would be square root of 2 over 2. Square root of 2 over 2 for cosine 45 degrees. Last example in the 7.1, it's identities. And like I said at the very beginning, if you're going to take math analysis or pre-cal next year, we will go into depth for this type of questions more. So this is serving as an introduction to the concept of identities. So for example, if you have sine theta equals 1 over cosecant theta, it's going to be true because it's identities. So, but how do I prove it? So just to tell you, just to show you the step here, okay, as a demonstration, I know sine theta equals opposite over, so that's from the definition, over hypotenuse. And cosecant theta equals hypotenuse over opposite. So from the sine definitions, if I write it like this, one over hypotenuse over the opposite. Do you see that this is basically the cosecant theta? So this is taking the reciprocals. 1 divided by hypotenuse over times opposite. 1 divided by hypotenuse over times opposite, which is opposite over hypotenuse. And that's just the definition of sine thetas. So like I said, we're going to go into more depth with the identities later on if you take on the math analysis or pre-calc classes next year. So hopefully some of the information that you learn in geometry will come back to you when you review this 7.1, and you will be able to add on to some definitions of cosecant, secant, and cotangent thetas.